My name's Layla. This is my impromptu ad hoc ad lib talk now. We're going to rock it. Well, my technical assistant gets my slides up eventually.
You know you've made it when you get an assistant.
So my name's Layla. I'm a developer advocate at VMware. I'm a Microsoft MVP, GitHub star, and I am the founder of Women of .NET. Lisa's a member of Women of .NET. Anyone can come and support women in the Women of .NET. Are we there? We're there? Yay! You can always come and grab me and talk to me about that. I am usually far more prepared than this, but I've been doing a lot of stuff virtually, maybe, because of something. So this is an Azure Functions, a guide to getting started. Who's used Azure Functions? Okay. Who's used V4? .NET 6 stuff, okay? Well, okay, we have a lone hand of that. I decided on Monday that I was going to update my really stable Azure Functions demo to V4 and .NET 6. Don't do that. Allow a lot more time. 2 days was not enough time. I did get it working on the other laptop. So we're going to wing it. We'll talk through code. We may not actually see live stuff flying around because I haven't got everything I need, but like API keys, but we'll be all right. It's fine. So I've already told you about that. That's me. Now, what are Azure Functions? Now, they allow you to develop more efficiently with functions, and it's an event-driven serverless compute platform that can also solve complex orchestration problems, build and debug locally without additional setup, deploy and operate at scale in the cloud, and integrate services using triggers and bindings. That's quite a lot to take on board, and you probably need to see some stuff to help you bring all that information together. But what they are effectively is something very small and lightweight that you can quickly get standing up. So why functions? Perhaps you have a big monolith and it's a little bit old, maybe it's on framework, and you want to use some latest .NET features, maybe something from C# 10 or whatever version it happens to be on, and you have a unit of work that you can take out. So let's say a notification system or something that's a processor. Maybe it has highs and lows. It's not in constant use. It's quite peaky. It's a very squeaky floorboard. Let me come over here. So something that maybe you can scale up really quickly. So anything that does processing, sending emails or text messages or processing files is a really good thing to abstract away and put into an Azure function. And as long as your actual application can go ahead and make an HTTP call, you're kind of there. So that's kind of what I think Azure Functions should be used for. They're like satellites around your own code. They can be used in a microservices architecture, in that distributed architecture. You can build them out in that way. So they are pretty versatile on how you can use them. So how do they work? So what happens? Let's take the HTTP trigger. There are lots of different triggers. We'll have a look at those in a moment. So you'll have an HTTP request come in, and that comes into the Azure world. And that comes and says, hey, I've got a .NET Azure function that I want to run, please. And so Azure goes, and all right, I've got a server over here. Why don't you go and use that server? And then that server's like, oh, what do you want? Well, I'd like functions runtime, please. So it then has to start that up. And then eventually, your code will get executed. And that's known as a cold start. And I think it can be like 7 seconds. I've heard things of like 22 seconds as well for that to come in. So that wasn't super desirable, really. I mean, if you want a quick response, don't go down this route. But the folks over at Azure were like, well, this isn't great. So I'll go back here. They changed this a little bit to have a warm start. So basically, they already had pre-allocated servers, this is how it works now, that have the runtimes on it. So you've cut that time considerably. Your request comes in. It's like, oh, okay, throws your code, your function, which is kept in blob storage, and it throws it up onto a server that's already hot to trot. So we've cut that time down considerably, and that's a warm start. There is a hot start function, which is when you deploy it onto your own app service. That's then like a web application. If you've got a web application, you can throw your functions in there. If you're already paying for it, you've already got that compute there, you can throw your functions in there and you'll have them hot. They'll always be ready. So that's the sort of two flavors, because they don't really do this cold start anymore, because it's just not great. So Visual Studio and Rider come with the Azure Functions built in. So you can go right-click, New Project, and get a Functions app on there. You can use the Azure Functions CLI tools, which I was going to show you, but we don't have those on this machine. So you can use that with VS Code if you're running it. So there's a whole separate thing. So normally on the CLI, you have like .NET New. You need to have the Azure Function CLI tool. So you would go like Func, it's F-U-N-C, and you would create a new Azure Functions from there. So it's not .NET New, it's Func init if you were going to create a new project from the CLI. You do need a storage emulator to run it locally. Now, you may have a storage emulator on your machine that came with Visual Studio, but that one is more or less not to be used anymore. And the thing to use is Azurite. So that's what you will be using on things other than Windows as well, and it works on Windows. So it is a cross-platform storage emulator, and you can start that up from your CLI, and it will just give you a whole load of endpoints for mapping for your different storage. Okay, so the core tools, I've probably covered this, but they allow you to develop and test functions on your local computer, which is really important because Azure Functions V1 was completely in the portal. That was hellish to debug. I was right there from the beginning, going in there, trying to debug these. It had all weird sort of things going on. You had these weird way of bringing in your dependencies. It wasn't a great experience. So with V2, you could develop locally, which is great because you have source control and collaboration and all of that cool stuff that you have with your normal development workflow. So they allow you to do that locally. You can connect to Azure services, and you can debug them. Yay, we love being able to debug without having to hook a debugger into the cloud. And then you can deploy your function app to Azure. Okay, so this is where I would go over to code, but let's see if we can magic up some code. I'm not going to show you this one. This, you have really tiny fonts. I'm going to have my nose. So let's open, let's create a new. So let's go a new project, and I'm going to see if I can find...
Scroll down, is it on the left?
On the left.
You just want,
oh, it's the opposite way, okay.
Under Cloud, General.
Cloud, General, thank you. There we go. Okay. So let's just call this Demo 1. I'm hoping this is going to put it somewhere that we want. And right here, you can see, if I use this laser pointer, we have all the different triggers. So you see we've got service bus, HTTP, timer, queue, blob, event grid. We've got some more down there. We've got IoT, like durable functions. I won't cover that today, but I'll tell you about those. SendGrid and all these sorts of things. So these are ready to go. You can connect into those, and the code's already kind of written for you. So we're going to do a demo first with HTTP trigger. I'm losing my voice. So let's go and grab that and create it. And sticking it there, these If it's wrong, it's wrong. Okay, so what we have is it's already more or less written for you. So it's a great way to go and learn with functions, is just go and create a new one. So there's some interesting things to do here. You'll notice that there's not really a program file when you start. We've got this host.json, and this will say what version you're using and things like that. And then we have this local settings.json, which is not much in there. And then you'll see there's a gitignore, and it's uncommon to get a gitignore with a template. And that's because, if we look in here, it has this line. So just know that when you, bigger, there we go, that's better for you and the back. So we've got this local settings.json, and that's because Azure Functions are really heavily convention-based. So they come and look when you run them locally in this file, in this values folder, specifically for connection strings and the things that they need. So they're being very kind, the people who write the template, and not letting you commit your secrets by putting that in the gitignore. So just know that that's there. And so it's good practice to have like demo.settings.json. So you have the architecture of your settings in your source code, not your actual secrets. So we've got that here, and we've got just it's going to use local storage. So hopefully we've got local storage on here loose. It probably came with Visual Studio. We'll see. We'll see. So let's go and have a look at the actual function itself. Let me unpin you. Okie dokie. So what we can see straight away is that it looks very similar to a method you'd write in a controller. This is your function name. This is what you will call. So this can be anything that you want. And then this is your method. So we've got an HTTP trigger function. You can set the authorization level. When you're developing locally, it's always going to be anonymous, but when you deploy, it will listen to what this is. This one currently takes gets and posts, and then you can specify a route, which is null in this case. It's going to use the default route. And then we pass through an HTTP request. So it's kind of laid it all out for you. And then if we go here, it then tells you how to get stuff out of your request. So if it was a get, it's going to get it from the query string, so we'll get name. If it's from the body, it's going to read out the body there, and then it will print some stuff. So let's see if we can actually get this to run. Dun, 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 dun. Tension. Looks like it might be going. Yes, okay. So I don't know, can I make this? Yes, I can make this bigger, hurrah. Okay, so let me grab that, pull this up. So what you get is it will print your functions out for you if they're HTTP triggers. So right now we can see it's got your function called demo1. It's a get and a post. And then you've got 7071 is the default port for functions, and then API/demo1. That's your default route. So it gives you that. If you had other types of triggers, it's going to pop those in there as well, and it will show you. But you can't poll a blob trigger, for example. Okay, so let me grab this. Okay. And then let's go and see if we can do that. And we can go to it. Okay, so you can see straight away that it's just gone the default route on there. But if we go and add something to the query string, name Layla, you can see it's pick that up out the string. If I was using something like Postman, I could do a body post there, and you can see how it picks out. So if you haven't done functions, it's a really good start. Just go in and play and see what you can figure out. So let's go back here. All right. But I'm not the biggest fan of just going, hello world, and sending you on your way. So I want to talk to you about something that's more than just a quick demo like I've shown you, an actual system that you could implement and how you might want to do it. So I have a transcription service. Speech to text is actually quite slow. If you have a 9-minute audio file, it takes about 3 minutes to transcribe it if the service isn't busy. So you want to make sure that you've got something that can deal with a lot of load coming through and passes it off appropriately. So we have this system, and we've got any old app can take that recording in, and then we can upload an audio file. And that's on an upload function. And that function will just take that streamed data and then save it. And it's saving it to blob storage. Now, what we have is a blob trigger. And the blob trigger is another type of function that's listening to a particular blob container to be updated. And you will give it, it will match on the file name that you use, and it will go and when that new blob item comes in, it will do whatever you have specified to do with it. And in this case, it's going to send off a request to a speech-to-text API, and it's also going to update table storage. It's going to create a row in there. And then finally, there's one more function, which is another HTTP trigger, which I use as a webhook. And the speech-to-text API calls that webhook when it's done and ready, and then we go and get the stuff and write it to the table storage. So that's kind of the system, and that's a very real-world type of system. If you had an audio processor, say you want to resize images or you want to do stuff with them, like apply filters, it would be a system like this. You'd probably send them to, is it Cloudinary that does all that type of thing? Okay. So let's go and have a look at some code. Now, this sadly, because I don't have my actual laptop, isn't going to be able to run because I need API keys and ports to open. And I need to find Visual Studio. Again, there we go. So let me, is there another instance of that? Yeah. And there we go. Okay. But we may be able to do a little bit with this one. So let me open it up, and we can have a little look here. All right, so it's got quite a few projects here. This happens to be a Blazor one. As I say, I updated it over the last few days to .NET 6. And we've got a few components. And then we've got a Blazor server application. So what I'm going to do is get that running. Is this only for GitHub, this terminal, Luce? No? No? Okay. Okay, so let me just see where we are. So we're going to CD into the audio spike Blazor. And we'll just do a .NET run on that and get that going.
Corporate laptop security.
Perfect.
I'll
Thank you.
in case you need it.
Okay, all right. So we've got that one. I've now got like a gajillion of these open. Let me go back here, go back up. And then I'm probably going to run the other one from here, the audio processor. Let's have a look. So this is the one I just described. And we have, this one does look a little bit different because you'll notice it's got a startup. So let's go in here. And this is quite an important point because this actually has dependencies. So you can use your dependency injection and the style of architecture that you might use on any old web app right here in your Azure Functions. So we've got that, so we can use a startup. Now, the way you can get a startup to come in is you have to do a little bit of decorating. We've got this here that goes outside the namespace, and you're telling it to have a function startup here. And then it needs to inherit from function startup, which inherits from, I believe, web jobs. I have no function key, so I don't know how to go in there, but it's fine. It's fine. Oh, function, there we go, okay. Gotcha. All right, so you can see that comes from iWebJobs and wraps that, so it's all in there. Now I've done it, how do I go back? There we go, I've got it. Alrighty, so let me close that one. So we've added dependencies in here. I've got user secrets that I could use, so we're strongly binding those using the options pattern that come in. So we'll have strongly typed configuration to use within the application. I've got HTTP clients. I've got TableDB context. These can be singletons because they're APIs. They're not using entity framework and things like that. And then various things to help with all of the transcription and writing to things down here. And then we have the configure app configuration settings down here like you would on another application. And we're telling it to use user secrets, add environment variables, local settings, things that you want locally so that you can actually bring in and bind those things. Alrighty, so come back in here. The data up here, it's just structured like any application. I will warn you with updating things like table storage up. They've switched all the APIs and the NuGet packages, deprecated a lot, so again, be careful with those. It's quite an interesting thing to have done an upgrade through this because the whole point is that Microsoft give good migration paths to this, but they're very much just about like how to update your project, CS proj basically, not about all the triggers that changed. So the blob trigger changed, and I'll show you how that changed in a moment as well. So the first thing we have is our upload function. And if I come down here, we have, just like we saw before, I've let this one do a get and a post. It really only needs to be a post. And this is going to stream in some audio. So it lets it come in and then does some binding and saves that off to blob storage. And that's all this does. And that's really important. You don't want any long-running processes on a function because they time out after, I think it's like 12 or 15 minutes. So you don't want anything that's going to take too long going on there. So you need things that are done and then moved on. That's why you have multiple functions. So that one will take the upload. And then back in here, the next one we have is the blob trigger. So you can see here I have constructor injection for my dependency injection, just as you would in your regular applications. So we bring in all the things that we need, and this is where it gets a little bit different from the HTTP trigger. So the other types of triggers are heavily convention-based, so you will need to go to the documentation and see what the conventions are for your application. So the thing that we have here first is the path to the blob storage. So I'm going to look for new blobs that have gone into audio container and that have this file path. They match this. So uploads audio and then some kind of ID. In this case, it's going to be a GUID. And then I tell it there's a stream. I'm going to get this ID, which is the GUID ID, which it gets out of the file here. And then I have a logger. Now, one of the problems when I upgraded, so those of you who haven't used v4, you used to be able to specify your connection string in here. And that connection string is in local settings. So you could specify connection equals whatever the key name for your string was. That's all changed. It has to be called connection. So I don't have a local settings in here, but I have a demo settings. So whereas before it could be storage connection string, I haven't updated this, but everything for your triggers, like your blob storage, has to be in this values object. It also can't be in user secrets last time I checked. So this would have to be connection. It has to have that name now. There's no way that I have seen in the documentation where you can specify that how you used to. So these ones do actually have to have your actual connection string in here. You can have other things down here which will bind to user secrets. So those can all be down there. So that's a big difference. It's very heavily convention-based, that it won't run unless you see you've got that there. I mean, it will run, but you'll get an error. Okay, so if we go back to that blob trigger, so we have set the thing that it's going to be listening to. We've got that. And then we come down here. We're getting some things out. We're reconstituting the file name. We've got the ID in there. And then we've constructed an audio URL based on what the path to the external path to our blob storage is. So things that you would have to do is make sure that the permissions on your blob storage are adequate. If they're locked and they're not externally accessible, the speech-to-text isn't going to be able to go in and grab it. So we build that, and then what we have down here is a lot of logging, because it's useful. And then we try and upload the audio sample off to the speech-to-text API. So this does that. And down here, you can see it goes off to a service to do it. And then we also save the audio details to table storage. So that's kind of the whole thing that bit of the function does. So again, it's not long running. It fires off an API request to a speech-to-text service, and it goes and updates table storage. So you can see it's quite snappy when it does that. And then that's it. That's all that one does. So then if we look at the final one, which is our download function. So this is the webhook. So if I scroll down here, we have, we've given this path to the API function. And when it's ready, it's going to call this. And this is another nice thing to have as an Azure function. You have a webhook, because they're not always called. They don't need to be alive all the time. You can have that external service call it when it's ready. So we do that, and then this goes in and says, OK, you're ready, and then it will go and make an API call and fetch the actual speech-to-text transcription. So that's kind of what that whole solution does. Now, it's not going to run, because I don't have the API keys. But what we would have seen, if I can go and explain, we would have seen that request come in. It would have fired off that download, the upload function. That would have gone. Then the application would have gone quiet. We would then see a few moments later the blob trigger would have fired off. So we can see that really nice asynchronous workflow. The blob trigger would have gone. It would have done its little bit of work, and then the whole application goes quiet. Followed finally by the download one, which would have got that request coming in from the third-party API, and then that fires. So you can see it's very discrete units of work, which makes for a really nice, efficient, cheap way of doing things. So apologies that we can't see that actually running. I just need to find... There we go. Okay, so let me start this again. So we've got that there. You could see how that was kind of architected in a traditional manner. So what do you need to think about when you are structuring these applications? Well, they can be structured like any .NET web application. You don't have to learn anything new. You can just build them like you would. You can structure them with multiple projects, external references, and things like that, and build it how you would normally do. So there's no new learnings there, really. It supports .NET Core's dependency injection, which is a nice workflow. I do get asked about why you would have dependency injection in functions because they're spooling up and shutting down. There is a lot of debate around that, but the time difference for creating these dependencies is quite small for the amount of decoupling and code management it gives you. It supports .NET 6, and just try to remember that single responsibility, trying to get your functions to do small, simple units of work. I can't stress how key that is enough, that you do these small little units of work. So, the money, always interesting. Functions are more or less free. Yay, we love free. You can use the consumption, which is pay as you go. It includes a monthly free grant of 1 million requests. Whole million. I mean, if you're doing some kind of fun project or some small-scale thing, that's a lot of requests. And then you get 400,000 gigabytes of data processing through it, and then it's 16p, it's gone up, it used to be 15p, per 1 million executions. So they are hugely efficiently cheap. They are so cheap, so unbelievably cheap. It's great, we like cheap. When you think about a web app, I think a basic web app, if you, let's not talk about throwing Visual Studio, SQL Server into that, it's going to be costing you like £35 a month easily. And it's probably more. So you can have that, all that sort of benefits without all of the cost overhead. A nice demo, actually, is if you are interested in Azure static web apps and things like that, built with Blazor WASM. One of the Learn tutorials on the Microsoft Learn platform is building an Azure static web app. So you use Blazor WASM in the front, but all of your APIs are built in Azure Functions because they're so cheap. They're free. So you can go and play with them and do things, and if you've got personal projects, they're not going to cost you anything. So they are great to go and play. And then if you are using them for business, they're going to be really cheap, really cheap. If you've got millions and millions of things going through, they're still really cheap. Now, the consumption plan is on that warm start, so where it's a little bit delayed. If you really, really, really need instant response, you can go for premium. So it offers the same features and scaling mechanism. Now, I didn't talk to you about scaling. Consumption plan auto scales. I think it's something like 200 instances it will scale to, completely on its own. And then Azure Functions Premium will scale to, I think, 150. You'll pay for it. So it does use that same auto-scaling. Yes, you can limit how much it scales to. You can control all of that with some caveats. It doesn't have the cold start because it's always alive, which is why you pay for it. And it does have some enhanced performance. So it's built based on the virtual CPU and memory that your function consumes. But you're going to have a baseline there. So it's going to cost you, I think, around the same as a web app, possibly a little bit less. But you're looking maybe around 25 to 30 as a base, as opposed to free. So the third option, which I mentioned, is that you can put it into an existing web app. You can deploy it with your solution as yet another project within your solution. So you can do it that way if you've already got a web app and utilize that compute that you're already paying for. So we spoke very briefly about security and authorization. So if you remember in the code, we had, if I go back, we had on any of these, this authorization level. So all the functions come with that. And then if we go back to, I maximized it, whoopsies. We come back in here. We can see that we've got these 5 types. Anonymous, anybody can come and get into your app. Function means that it's based on the per function. It's localized to that function. Admin is admin only, which I think is set up within the Azure portal. System means anything within that system, and then user. So there's various different points in there. There is something that came out last year where functions all in the same ecosystem automatically can chat to each other. They don't need, they're not isolated. They're considered inside the same little room, and there's freedom of speech through it. So there is some different security within there, like internal behind the wall. But I am going to put a big but here. Do not rely on these authorization keys. Please don't use those as your only security unless your API really does nothing much of any import, as in a security point. Obviously, what you're going to write is important, but if it's something that is sensitive, please don't rely on these keys, okay? You need to secure your HTTP endpoints properly. So you can enable app service authentication and authorization, so quite heavy. You can use Azure API management to authenticate requests. So, and you can deploy your function app in isolation. So that protects it from its friends, and then you can have a gateway in front. So the app service authentication is going to be like Azure ADs, things like that, any kind of authentication like OAuth and things like that. So you basically allow access through that. And then the Azure API management, if you are using your APIs in a business manner, so you're selling them on, and you have, that's your main bread and butter for earning money, then you may want to think about the Azure API management. It's very expensive. I think when I last checked, it's about $1,500 a month. So it's really pricey. But say you have things behind there that you really want to keep nice and safe and secure, that's going to manage it. It's also going to do all the things that you might need for your API management, such as rate limiting, user authorization. So if you're having different tiers of subscription, perhaps, to the service, that management service is going to do all of that for you. So it has a lot going on in there if your business is API management or API reselling. But it's very pricey. So you can get away with a lot cheaper using just app service authentication. There are tutorials on how to do that, and the identity team at Microsoft, Christos Matskas, he'll always help you. He's helped me with how to do that kind of thing. So last year, we were given something called an isolated process. This was so that you could run your applications, your functions, using .NET 5. So we've got two things. The functions run in process or they run out of process. Everything but C# runs out of process, okay? So they enabled C# to run out of process as an isolated process. And that allowed you to use .NET 5 in the latest features. So what it does is it gives you full control over the language worker startup, so you can have a program in there, and it allows you to configure more features. Now, you can see that we have had dependency injection in the applications that are in process. This just gives you more. So you get a program file. You have more control over the startup and things like that. And then with .NET 6, you can now run in and out of process. So you can choose which way suits you. In preview now as well, free preview, so you can go and play with this for free, is functions on Kubernetes. So if you have a pre-provisioned cluster, that's not free. That's very not free. You can stick your Azure Functions on there. I haven't played about that, but I only found out about that on Monday. But I think that's pretty cool. You can run Azure Functions in Docker containers as well. I think my next slide is going to show you all the places that you can deploy that. So we've got the consumption, premium, app service, and then the new things that I'm going to tell you, Kubernetes, Azure Stack, so that's your Azure on-premise, and then IoT Edge. I haven't looked into the IoT. I'm not quite sure what that is going to look like, but it is a possibility. So you can have these super lightweight functions on any of these things. So V4, which came out last November, well, GA'd last November, it has the in-process and isolated process. It also supports Node, Python, Java, PowerShell, and then custom handlers, so you can do some other sort of things with it. I hear the PowerShell ones are really popular as well, so if any of those things float your boat and you want to play with them, you can do that with Azure Functions. And they can all talk to each other and do things, so it's very cool. So if you want some further reading, I would say go check out the documentation. I will give you a link to these slides, so you don't have to take a photo of this. Configuration is quite an interesting thing. That one might be a bit out of date now, that blog, because all the configuration is changing a little bit. If you want to see actual like charts of the different speeds with cold starts, because lots of people, the things they say to me, well, they're cold starts, they take too long to start. It's really not that big a deal. I urge you not to let that stop you using Azure Functions. The cold start really isn't that big of a deal. When you go and look at it on this blog site and you see the charts there, you can see that it's not really a problem. And then there are a whole host of really interesting blog articles and how-tos on the latest features on the tech community blog at Microsoft. I found a whole load of things, and there's loads of news and updates on there that you can go and have a look at. So I think that was pretty cool for things like that, as well as general blogs on them. And then that's it. I would have taken a bit longer if I'd gone through my whole demo, but we can have questions and we can go back and look at anything. So you can get to my GitHub repo, which is Layla-P. This is the demo I did was on there. I have another one on there that's slightly older, and that's a photo processor from the talk I did a few years right here on this stage with Luce. We built a Xamarin app live here, and I made an audio processor that processed images. So if that's something that's interesting to you, you can go and have a look how the processor system works for that. Very similar setup to this audio processor that we have. But you can go and have a look at that. You can get all links to my stuff on layla.dev and, again, womenof.net if you are interested in that. So we have time for questions, and we can go through, and I will do my best to answer them. Does anyone have any questions? Yes? Is there a what runtime? Yes, so it's the functions runtime. So is that what you mean, master? Oh, sorry. I really struggle with hearing in rooms like this, so please excuse me. Yes, so I believe they will run for 15 minutes max, I think. That's off the top of my head. It could be 30. I'm doubting myself now. But there is, okay? So you do not want these to do stuff. I think the max, I would safely say, you should do is 5 minutes, no more, because they really don't like it. And then that's it. They're very lacking in state. So really try and keep things, think about how you architect systems to do one thing and then let something else pick it up when it's ready. I think that's what I've tried to show with that audio processor is how you don't want to be hanging around waiting for responses. Nothing you do with functions should be waiting on a response from something because they just won't be around. Did you have one? Oh, there's someone behind you, Steve. Then you can go. Okay, right, Steve, go.
When you did the new default template,
yes,
it's using user.json rather than system.json. Is that a Azure Functions thing?
This is a whole nother thing. Thank you for pointing that out. That's a really valid thing. So Azure Functions don't work with system.text.json, okay? This stumped me for a long time. If we go back and look at this code, it's a really good question because these sorts of, you know when I say they're heavily convention-based, they are. Now, in these models, I have this webhook response. Oh, that's another point that I can point out. Let me just show you where this comes in. If you look at the other triggers, do you remember they had an iHTTP request here? You can write custom models, and they will bind to those, okay? So that's a really cool feature of them. But if you are writing custom DTOs or view models for this to come in, when you go to them, and you maybe want to put some decorators on them, I had the system.text.json decorators on here, and I was like, why is this not binding? Why is everything blowing up? They are written for Newtonsoft. You can use system.text.json to do your serializing and deserializing, but if you are looking at decorators that the binding and the internals of your application are going to use, you have to use Newtonsoft.json. Okay, so it's yet another, they're very, 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 very opinionated. Okay, that is all you need to bear in mind when you're using Azure Functions. They are so opinionated and so convention-based. Right, you.
So my question was going to be about triggers. So
Yeah.
Can you, to what extent can you simulate that on your local storage or local machine? So for example, blob storage trigger, do you get blob storage locally that you can just drop file in to cause that?
Yeah. So you can either use the local emulator or you can connect directly to Azure. So this actual demo would have used my Azure blob storage connection strings live and ready to go. And so the app would have been talking there. And to test locally, I use ngrok to open up a port into the computer. So if you feel comfortable using ngrok, it's a tunneling app, so not everyone is comfortable with opening up tunnels through your firewall, but if you wanted to test the whole system locally, you can use something like ngrok to do that. That's for like the webhook coming in. But you don't need that if you want to connect for your app to talk to your live Azure blob storage or table storage and things. But equally so, you can run them on Azurite, and they'll be there. So Lucy, you might actually have Azurite because it comes with Visual Studio, I think.
Okay. You can install anything you like, I don't mind.
Let's see.
I got a new laptop about 3 weeks ago, which is why I'm living very light.
Okay, so lots of things I can do with Lucy's laptop.
Let's not talk about that.
Okay.
Never happened, okay?
It's not the first time I've had to present with someone else's laptop. I remember I was in New York and I was just about to go on stage and my computer said, no, I have to do my update now and you cannot delay this. So it's not the first time. So it's one of those facts of lives. So if we have a look at Azurite, it's going to tell me about a rock. So let's go Microsoft. So I just wanted to see if it's going to have a nice picture to show you. So if I go and look at the Visual Studio Code, I think if you've used, there's like a data explorer for, like a lightweight data explorer that you can use instead of SQL Manager Studio, SQL Management Studio, because you can't, that's a Windows only thing. So if you are developing on a Mac, you can't use SQL Server Management Studio. So there's a data studio that you can download, and they look like Visual Studio Code. So Azure, again, looks very much like that. So you have like this nice GUI to look at, but you can also run it straight off the command line, and it will give you all of these HTTP endpoints. If I go down, is it going to show? Yeah. So it will show you, like, what's your blob host? And it will give you it will say local host, and then it will give you a port and things like that. So it will give you a lot of, you've got queues in there, so you can do your queues and table. So you can do all of that locally really nicely. So I think it's a really good system for that. Any other questions? Yes?
Can you trigger the same function using multiple different triggers?
Yes. So you can have different functions calling the same trigger.
Different triggers calling the same function. So, for example, a HTTP post or from a queue.
So they are bound to be a particular trigger. If you needed that, you could encapsulate your code and have a blob trigger and a HTTP trigger that call the same method. That's how I would suggest doing that, if that's what you needed to do. But you can't have them combined. You can't have like a run method that has a decorator for a blob trigger and a decorator for HTTP trigger. They need to be separate functions to give them their endpoints. But the code, the gubbins of that, you could extract out and use. If I show you durable functions as well, if we come here, if there's usually a nice diagram. Now, durable functions, I always get asked about these. I've never bothered to play with them because they are really expensive. And I'm in this to play with like free stuff. And the things I've heard is that, and what I see from the architecture, I'm going to show you them because I want you to see, is that durable functions, yes, they are an orchestrator, but the out-of-the-box Azure functions can do a lot of that if you architect them well. And I don't think durable functions are really worth that. I read an article about a company that switched from durable functions to regular functions. They just re-architected them slightly, and they saved themselves like $60,000 a month, something ridiculous. So I think you really need to know that you need durable functions. And durable functions work in several different patterns. I'm just going to show you the pictures because they'll give you an idea. So you can see process to process to process. And then, you know, some of these things are more complicated, and this is why you might need an orchestrator, such as the durable functions, but really think about, can you do it another way? So you can see that they do stuff and then fan out and will call multiple triggers. But could you have a function there that does that for you? Could you have one that calls those triggers? And that's the way I think about it. So you've got these other ones. This is kind of similar to what we had, different ones talking to different data storages. If we go down here, they can chat to each other, monitoring each other. Human ones, so there is one that will ask for a human to go and do something. And then I think, is that it? Aggregators. So, you know, there's quite a few things there that you can do. I've just never seen anything that I've really felt I need to step up to durable functions for. The regular functions, if you do them in a thoughtful, logical way, you can get most of the way there. Does that answer your question? Yeah? I know I went on a bit after it and did more, but yeah. Any other questions? Anyone inspired to go try them? Oh, good, yay. There were a lot of hands there. Go straight to V4 and .NET 6. Don't do V3, just don't, because the upgrade is going to be horrible. And you can use all the lovely new shiny features of .NET 6 and C# 10. That's what we're on, isn't it? 10? They're coming around so quick, I can't keep up anymore. All right, well, thank you very much. If you think of any questions, you can hit me up on Twitter, nicely, not like a... and again, my apologies for not giving you the full beans demo. And a thank you to Luce for being my savior and giving me a laptop so I could present that to you. So thank you very much. Enjoy the rest of your day.